Every night we look at the sky without even thinking about what amazing worlds are right next to us. The Moon, Mercury, and even our own planet Earth still hold many mysteries. To uncover them, humanity sends the most complex spacecraft into space, which travel for years through the void for the sake of a few photographs and scientific data. It is thanks to these missions that we are beginning to understand what our cosmic home is really like.
Mercury. A world of hellish heat, bitter cold, an extremely thin atmosphere, and huge craters. In past centuries, the tiny planet was actively studied by stargazers from Assyria, ancient Greece, Egypt, China, as well as Indian and Arab astronomers. Galileo Galilei was the first to see Mercury through a telescope in the 17th century while observing the phases of Venus. After that, many scientists observed the object. Pierre Gassendi, Giovanni Zuppi, John Bevis, and Egon Schroeder. Research continues even today. But now, Earth spacecraft are orbiting Mercury, gathering information bit by bit. And yet at this moment, it is the least studied planet in the solar system. Why? Let's try to figure it out. Sending a spacecraft to Mercury is too difficult a task. That's why it has only been visited by 2 probes, Mariner 10 and Messenger. Currently, no Earth spacecraft is capable of a direct flight to the planet without using multi-stage gravity assists. To enter a highly elliptical orbit, the probe needs to slow down sharply, but to approach Mercury's surface, it actually needs to speed up. Velocity changes consume massive amounts of fuel. That's why, throughout the history of astronautics, it hasn't been possible to send a larger number of spacecraft to the vicinity of Mercury. But those that have visited the planet's orbit have sent many photographs and data back to Earth, helping us understand this strange world. Mariner 10 set off for Mercury in 1973. Interestingly, this was the last spacecraft of that series. The others were renamed Voyagers. For the first time, a small 500-kilogram probe equipped with solar panels flew past the tiny planet in March 1974. The closest approach to Mercury was about 320 kilometers. In total, the spacecraft made 3 orbits around the celestial body. Despite such a short stay, the probe sent quite a few images back to Earth. With their help, a map of 40% of the planet's surface was created. Humanity saw the 135-kilometer Boccaccio crater with a tall spire inside. It examined a chaotic geological region of unknown origin, believed to be the result of seismic activity and destruction, an amazing crater within a crater. Hesiod plus Discovery. Mariner 10 was the first to discover that In terms of cratering, Mercury even surpasses the Moon. In addition to the deep scars left by asteroids, the planet is covered with cliffs up to 2 kilometers high. The probe revealed the virtual absence of an atmosphere, represented only by a thin helium haze. The temperature readings from Mercury transmitted to Earth by a 20th century spacecraft differ significantly from current data. Back then, the temperature ranged from plus 180 degrees Celsius during the day to minus 183 degrees at night. Modern data shows that daytime on Mercury is incredibly hot, reaching up to plus 500 degrees Celsius, while at night the temperature drops to minus 190. This means that on this tiny planet, there are the most significant temperature fluctuations in the entire solar system. The next was the Messenger probe, launched by NASA in 2004. The spacecraft reached its destination in March 2011. It was better equipped than its predecessor. The developers tried to protect the probe from solar activity 11 times stronger than in Earth's orbit. The 1,000-kilogram spacecraft was wrapped in multi-layer thermal insulation material and covered with a sunshield. A special system of collectors was used to dissipate excessive heat. The interplanetary spacecraft was packed with a variety of scientific research equipment, cameras for topographic and detailed imaging, spectrometers measuring X-rays and gamma rays, and instruments for detecting high-energy particles. An altimeter and a magnetometer were integrated into the body of the probe. On a January evening in 2008, after exhausting maneuvers and orbits, the Messenger probe flew close to Mercury for the first time. But only on March 18, 2011, due to the difficulties described above, the spacecraft entered a highly elliptical orbit. It took 6.5 years to do this. Amazingly, the spacecraft sent to Pluto took only 3 years to get there. The probe's mission is to last for 2 Mercury days near the planet's surface. This means that Messenger has to orbit the celestial body for just under an Earth year. During its first flyby in 2008, the spacecraft sent valuable images back to Earth. For the first time, the side of the planet that had never been seen before was photographed. During the mission, up until Messenger's crash in 2015, more than 227,000 images of Mercury were taken. In 2010, the probe took a family portrait of the planets of the solar system. This is a kind of challenge that was started by Voyager in 1990. Messenger also recorded the largest Mercurian crater with a diameter of 1,550 kilometers and an age of 3.9 billion years, the Caloris Basin. 11 years after its launch from Cape Canaveral, Messenger, having used up all its fuel and more than fulfilled its mission, crashed into Mercury near the Janacek crater. Unfortunately, the moment of the crash was not recorded. It was impossible to do so for that long. But the main question facing the initiators of such expeditions is the possibility of colonizing the planet. Is this goal achievable? At the moment, the planet is lifeless. There is a hypothesis that there is water ice on Mercury. Where did it come from? From comets that periodically visit the celestial body. The vapor travels across the surface and settles at the bottom of polar craters that have never seen sunlight. If we don't take into account the complicated journey to Mercury, the same methods used for the Moon will be applied to its exploration. The presence of valuable resources and significant reserves of solar energy, substantial gravity, and a large core make the planet a possible outpost for future Earthlings, at least at the level of inhabited stations. Earth is the cradle of human civilization. But the fields, mountains, oceans, and blue sky, the view we are used to seeing from its surface, is somewhat subjective. From space, Earth looks completely different, as evidenced by numerous photographs. Why did we suddenly decide to talk about our own planet? First, it is just as much a celestial body as billions of others in the universe. And second, on April 22nd, its inhabitants look forward to Earth Day. Earth Day is meant to draw humanity's close attention to the fragility and vulnerability of our planet. Earth is a unique celestial body, similar in some ways to other members of star systems. It's the third planet from the Sun, the largest of all the terrestrial planets and the most spherical. But what makes it so? Its uniqueness lies in the fact that Earth is the only planet known to science where life has originated. Not on Mars, not on Venus, not on Mercury. There are no rustling forests, no babbling springs, and no intelligent beings bustling about like large ants calling themselves humans. Not many of us have had the chance to see Earth from the outside, but only a few have been lucky enough, for example, the temporary residents of the ISS. For the most part, its image has been captured by numerous probes, and not just from up close. How did this years-long photo session begin? The world's first photo of Earth from space was taken from the suborbital rocket A4, or V2. It was launched from the White Sands launch site, and after some time reached its apogee, which was 105 kilometers above the Earth's surface. It was from there, on October 24th, 1946, that a series of photographs was taken, which amazed the whole world. There would be many more significant, amazing, and memorable images to come, but this one will forever remain in history as the pioneer photograph. Everyone knows that on April 12, 1961, Yuri Alexeyevich Gagarin became the first person to travel into space. Strangely enough, the astronaut did not take any photos. He only described what he saw over the radio. Therefore, the first astronaut to photograph the Earth was Alan Shepard, who made a suborbital flight in the same year as Gagarin. He took a picture of our planet from an altitude of over 180 kilometers. Later, on August 6, 1961, similar actions were taken by German Titov, the youngest Soviet astronaut. Take a look at one of the most controversial photos that appeared in 1972 during the Apollo 17 astronauts landing. In it, Harrison Schmitt is planting the US flag against the backdrop of a tiny crescent of distant Earth. For many years, there were debates about whether this photo was staged or real. History will settle the debate, but if you look at other photos showing the Earth and the Moon, there is no doubt left. The events really took place outside our planet. Let's leave the skeptics alone and turn to other, no less epic photographs. One of the most famous photos is the Blue Marble. It was taken on October 7, 1972, once again, by the crew of Apollo 17, After that, the photo instantly spread all over the world. In the famous image, the Earth is seen from a distance of about 29,000 kilometers, generously illuminated by the sun. The next photo clearly demonstrates the change of day and night, the so-called Earth's terminator. The photographer is one of the astronauts of the Apollo 11 mission. This imaginary line passes through every point on our planet twice a day, in the morning and in the evening. It might be right over your city at this very moment. From which celestial body was the Earth photographed for the first time, not counting the moon? It's not hard to guess, from the vicinity of our closest neighbor, Mars. The image taken by Voyager 1 in 1977 doesn't have high resolution, but for the first time, it shows our planet together with its satellite as a cosmic mini-conglomerate, outwardly not much different from other members of the solar system. A curious viewer might protest, why are we looking at these ancient images? What about modern telescopes and probes? Didn't they capture anything worth attention? Of course, there are plenty of recent photos of Earth. For example, a striking image is the unfolded view of the globe, showing the nighttime illumination of different parts of our planet. This photo was taken in 2016 by the Suomi NPP weather satellite. As you can see, spacecraft are gradually taking away people's right to independently capture the accessible corners of the universe. The next image also comes from the cameras of the artificial lunar satellite Kaguya. In the photo taken in 2018, you can once again see the Earth through the eyes of its faithful companion, the Moon. Exactly 10 years later, the Chang'e 2 probe, which visited our satellite together with the Chinese relay satellite Chang'e 4, transmitted several images of the Earth from the lunar surface, including this one. It shows a sharp contrast between two opposite worlds, the dead rock, thickly covered with regolith, and the living, hospitable planet. Are these the only documentary shots that humanity possesses? Not at all. The Earth photo session is just beginning, considering how many plans for launching automatic interplanetary stations NASA has announced in recent years. In the meantime, let's go back to the existing images. There are quite a few of them. Here's the first image. The DSCO-VR satellite, located 1.5 million kilometers from Earth at the Lagrange point, managed to capture a unique sight. It's the Moon passing across the Earth's disk. Voyager 1 is not the only one who managed to capture Earth from the vicinity of Mars. Also, from the surface of the red planet, the Curiosity rover managed to capture it as well. This happened in 2014 from a distance of about 160 million kilometers. What about photos of our planet sent from the vicinity of other objects besides the Moon and Mars? There are such photos, in fact, even more than you might think. Let's go in order, starting with the first planet from the Sun. On May 6, 2010, the Messenger probe captured Earth and the Moon from the orbit of Mercury, which at that moment was at a distance of 183 million kilometers. In the image, both objects simply look like two bright dots. An interesting story happened in 2013 with the Cassini probe. The spacecraft was filming video so thoroughly and passionately, so focused on Saturn, that Earth accidentally ended up in the frame as well. Of course, it's impossible to see the Moon from such a distance. And here is the intermediate result of the work done by the OSIRIS-REx probe, which was sent to the asteroid Bennu to collect soil samples. In the first image, you can see the Earth and the Moon from a distance of 5 million kilometers, and in the second, from more than 63 million kilometers. But the most distant image of the Earth, the legendary pale blue dot, was taken on February 14, 1990, by Voyager 1 from a distance of 6.4 billion kilometers. That is near the orbit of Pluto. A lonely, dim, barely visible little star, which is our only home, looks lost and alone in the cosmic darkness. What can't we imagine the night sky without? Which celestial body directly affects many processes that happen on our planet, Which superpowers are competing for leadership in exploring the surface and interior of this object? Of course, you've guessed that we're going to talk about the moon. The presence of this satellite, as well as its possible absence from our sky, has a global impact or could have an impact on human activity. That is why the detailed study of the largest object closest to us is a top priority for giants like the United States and China. Here we see the age-old struggle for supremacy and resources. These are the two problems that have plagued humanity throughout its existence on Earth. But who will win this space race? Let's be clear. For now, China is in the lead, while NASA with its Artemis program is trailing behind. So, the moon. How exactly did it form, and when did it become our neighbor? There are three main hypotheses about how the satellite appeared in our sky. The first says that the moon and the Earth formed from a common protoplanetary cloud. The second claims that the Earth, as a larger object, once captured the moon with its gravity and forced it to orbit around it. But the most popular hypothesis, supported by soil sample results and other research, is the giant collision or giant impact. This refers to an ancient collision between the Earth and an object similar in size to it, roughly the size of Mars. As a result of this catastrophic event, the moon was formed from the debris. What recent news from the scientific world has partially confirmed the latest theory? They are connected to China's activities, specifically the Chang'e lunar missions. The tasks assigned to them involve studying the surface and interior of the moon, since the project is part of China's global lunar program. Chang'e 3 delivered the U-2 lunar rover to the moon. Chang'e 4 contributed to the landing of the U-2 lunar rover on the surface of the satellite. Chang'e 5 delivered lunar soil samples to Earth in 2020 for the first time since 1976. But Chang'e 6 did something in the summer of 2024 that had never been done before. It collected soil from the far side of the moon. In fact, there were quite a few unique events during this mission. For example, U-2 took the first ever close-up photo of the far side of our satellite in the history of space exploration. Since it's impossible to directly transmit signals or send data to Earth from that hemisphere, because the moon is tidally locked and always shows us the same side, China took care of this problem in advance. Back in 2018, a relay satellite called Queqiao was placed at the Lagrange point between the Earth and the moon. This satellite acts as an intermediary, transmitting valuable information to the Chinese Unmanned Spacecraft Mission Control Center. By the way, the lunar rover U-2, even while in sleep mode, had to endure the harsh temperatures of the lunar night, when the instruments showed around minus 190 degrees Celsius. The rover is still on the far side of the moon and is moving across it extremely slowly, literally feeling its way as it explores the surface of our satellite. The turtle-like speed is explained by the characteristics of the soil, which are different from those on the visible side of the satellite. At the same time, the lunar rover set a record for operational duration, as it worked on the moon for 340 Earth days. So, what did the device discover on the far side of the moon? The thing is, China is in no hurry to share important news or sensational discoveries with the world, partly because they don't want to help their main competitors in the race for the mission organized by NASA called Artemis. However, some information still leaks into scientific journals like Science and Nature, and accordingly, onto media portals. At the moment, it is known that on the far side of the moon, the Chinese spacecraft discovered unusual and orthosite glass beads, which most likely have an impact origin. They were immediately dubbed meteorite glass. Apparently, they appeared here as a result of asteroid impacts, when the surface literally melted from the high temperatures caused by the collisions. U-2 also discovered olivine and orthopyroxene, which probably reached the surface from the moon's mantle, again as a result of impact events. Radiation levels on the surface of the satellite were also measured, by the way, for the first time as well. It turned out that these levels are almost twice as high as on the ISS and 200 times higher than on the surface of the Earth. A unique biological experiment was also conducted on board the lander. The special container held seeds of potatoes, rapeseed, and other plants, as well as Drosophila fly eggs. After the lunar landing, the seeds were automatically watered. Later, some of them sprouted, which became a biological sensation since this was the first case of seeds sprouting on the surface of another celestial body. Which discovery made by the lunar rover Yutu-2 caused the biggest public stir? A strange object that the device noticed in December 2021, about 80 meters away from itself. It was a cube-shaped object of unknown purpose, but that was only how it looked from a distance. Upon closer inspection, it turned out to be a rock of an unusual shape. Most likely it broke off from something larger and was ejected from the depths of the crater. At the moment, Yutu-2 remains in the von Karman crater, continuing its observations and periodically going into hibernation when another lunar night falls. That's how China found itself ahead of the rest of the world and was the first to begin exploring the far side of the moon, the most mysterious and unexplored part. What can be said about Chang'e 5? Where and when did the spacecraft, named after the Chinese moon goddess, land on the moon? On December 1st, 2020, the returnable spacecraft successfully landed on a basalt plateau about 2 billion years old, located in the Ocean of Storms. This is the largest lunar mare on the visible side of the moon. The Ocean of Storms is about 2,500 kilometers across, and its area is about 4 million square kilometers. Chang'e 5 not only landed on the moon, but also collected more than 1 kilogram of lunar soil samples from the specified area and delivered them to Earth. The capsule landed in the wild steppe of China, in a region called Inner Mongolia. What surprised scientists when the results of the lunar soil sample research were partially released? The age of the rocks found on the basalt plateau was about 2.5 billion years. That's not surprising because the location is relatively young, but one fragment was much older. Its age is estimated at about 4.2 billion. Its appearance here remains a mystery, just like the fact that, among the glass beads in the form of small spheres, very young samples have been found, whose age does not exceed 123 million years. This completely disproves the theory that volcanism on the moon ceased about 2.5 to 2.9 billion years ago. But why haven't we seen volcanic eruptions during visual observation of our satellite? After all, even small-scale events like that can be seen through a telescope. The answer to this question is still unknown. In any case, this casts doubt on current ideas about the satellite's geology and requires further research. What other sensational discoveries awaited the scientific community in connection with the activities of the Chang'e 5 mission? A new phosphate mineral was found, the sixth element discovered by humans on the surface of the moon. Chinese scientists also extracted water from lunar soil samples. This happened during the heating of the material. Here, practical application of knowledge is involved, for example, during the colonization of the moon or the creation of a transit base on it. If you can get 76 milliliters of water from 1 gram of lunar soil, then from 1 ton, you can get 76 liters of water, which would be enough for 50 astronauts for a whole day. This fundamentally changes our perception of the dead surface of the satellite and makes plans for its development more realistic. And finally, Chang'e 6. What was it about this spacecraft that managed to surprise humanity? First and foremost, it was the fact that, for the first time in history, it delivered 2 kilograms of soil from the far side of the moon to Earth, specifically from the Apollo crater. At the same time, the spacecraft deployed the national flag of the CNSA on the surface. There had been no earthly symbols at that location before. Drawing on the experience of the previous automated station, Chang'e 6 delivered soil samples to Earth on June 25, 2024, and to the same region, the Inner Mongolia Autonomous Region. Preliminary results of the study of rocks from the far side of the moon are being covered very sparsely in the scientific press. In particular, it is noted that the soil at this location is more porous and loose, and that a lot of plagioclase was found in the sample. The mineral is considered igneous and quite common in space. For example, it has been found on the asteroid Itokawa. Another important point is that the delivered soil contains extremely few rare earth elements, potassium and phosphorus, the so-called creep. This fact significantly distinguishes this sample from those that were delivered by the Chang'e 5 probe and the Apollo missions. This is yet another piece of evidence of how different the visible and hidden hemispheres of the moon are in their physical and geological characteristics. It is worth noting, though not obvious, that such a difference, as well as the discovery of rocks similar to those on Earth, may be indirect evidence supporting the giant impact hypothesis. But what about the main competitors in the US-China space race? Unfortunately, the Artemis program has not had as much success as its Chinese counterparts. This research program was established in 2017 by the controversial politician Donald Trump. So far, only part of the Artemis I mission has been successfully completed. The unmanned Orion spacecraft, launched from Cape Kennedy in 2022, spent 25 days in space and traveled for 3 days in the opposite direction of the moon's rotation. This is called a retrograde orbit. However, Artemis II and the subsequent stages of this mission are highly uncertain. They planned a manned flight of the same Orion spacecraft, followed by the landing of astronauts on the surface of the moon and the launch of the Lunar Gateway Station. However, if this plan is ever destined to come true, the Chinese are currently far ahead of their competitors. And the problem is not just in the usual competition. The thing is, if the People's Republic of China's spacecraft managed to discover valuable resources on the moon, it's quite possible that representatives of this country will monopolize the explored area of our satellite, not allowing anyone else in. There are particular concerns about the PRC's plans to reach the moon's south pole, where, according to scientists' forecasts, there may be a large accumulation of water ice. Read between the lines, a valuable resource, especially in the context of future colonization. As for America, so far all they have are long-term plans. By 2030, a landing at the moon's south pole. By 2031, a crewed landing on the moon. By 2032, landing on the satellite with the delivery of a lunar cruiser, and so on, including the Artemis 10 mission, which involves a long stay of astronauts on the surface of the moon, up to 2035. What do you think? Is it possible to realize these ambitious plans? And who will be the first to achieve at least some of these goals? Considering the speed at which Chinese technology is advancing, as well as the enthusiasm, even fanaticism, of scientists from China, the answer to the question is obvious. Of course, it's not fair to say that NASA is inactive. Anti-radiation vests, launch vehicles, CubeSats, ultra-small artificial Earth satellites, and innovative types of lunar spacesuits are being developed. To sum up the interim results of the space race, the US and China now have a common goal. Who will be the first to reach the South Pole of the Moon? What makes it so remarkable? First of all, the presence of water ice. Secondly, it is believed that there are craters of eternal darkness there, unique traps, where matter is preserved from the early stages of the solar system's formation. Thirdly, an important aspect for future missions is the hypothetical peaks of eternal light, points on the moon's surface that allow equipment to be continuously recharged with solar energy. For example, during the lunar night, since they never go into shadow, will the exploration of the moon, and being the first in this matter, considering the major players who have entered the competition, affect the balance of power and the global geopolitics? Share your opinions in the comments. Well, Earthlings, this is not the end of the video. There are still some very interesting and truly spectacular episodes ahead of us. But for me to keep delighting you with all the wonders of the cosmic expanses, I need your feedback. You can express it quite simply. All you need to do is leave an electronic like on this video, since we simply don't have any other likes, and continue the phrase, "I know." This way, you'll let me know that we're moving in the right direction. Don't switch channels.